Good morning. Welcome back. All right. So today we'll take the next step in what we are doing. All right. So we first started by looking at linear equations, and we just said that they were equation of a line. And then we started to calculate the slope, or the slope, where it was we had 2 points, y2 minus y1 over x2 minus x1. Then the next day, which was last class, we talked about proportional relationships. And a proportional relationship, we said, was where the dependent divided by the independent variable was constant. When you looked at a graph, it had to be linear, and it went through the origin, all 0, 0. So today we're going to take the next step, and this is probably the most common thing that we deal with the linear equations. Most people remember this, and it's something called slope-intercept form. So what is the equation of slope-intercept? Anyone? Cricket. There is. So the slope is m and the y-intercept is b? Yes, that is true. So today, the difference between what we did today and what we did yesterday was, or last class we dealt with proportional, so it was linear and always went through, or it intercepted the y-axis at 0. Today, we're going to look at equations that intercept the y-axis at a point other than 0. Hence the interception here. All right, so there's 3 forms of linear equations. The first one is slope-intercept. That's the most common. That's one that most people remember. The second one is standard form. And the third one is point-slope form. And it's really simple. They basically tell you what they are. This one gives you the slope and the y-intercept. This one's standard. That doesn't tell you much. This one gives you a point, and it gives you a slope. And you can figure out what the equation would be from there. So because we are not in school for this, and we've lost a lot of classes, we are only going to look at slope-intercept form. That's the most important one. So what is slope-intercept form? Well, there's an equation for it. It's y equals mx plus b. Y equals mx plus b. Sing it. Y equals mx plus b. Yeah, y equals mx plus b. All right, you got it? So here's the way it works. In the form, slope-intercept form, you're going to have 4 different variables. Now, when you write the actual equation, you're only going to have 2. You must have 2 with one little exception. We'll get into that. So y and x are always going to be there. M is going to be a number. M is your slope. We already covered that. B is called your y-intercept. That is where this line intercepts the y-axis. Now, there is a second intercept called the x-intercept. There's no variable for that. We only use that with standard form. Since we're not going to cover it, you'll get to that with Mr. Litvak in 8th grade. Not that big of a deal. Okay, but the big key is your m variable is positive, and your by-intercept is positive. Important to remember. So what we're going to do is we're going to take some time to identify what is your slope and your y-intercept. So it's pretty simple. This is what a regular equation is going to look like. So you got y equals 4x plus 5. So y equals mx plus b. Y equals mx plus b. So m is the coefficient with your x term, or your independent variable. So that's going to be my slope. In this case, my slope is 4. Okay. And my y-intercept is whatever number is being added onto it. So my b, or my y-intercept, is 5. So my slope is 4. My y-intercept is 5. Yes, it is that easy. Okay, y equals negative 3x plus 7. So m, my slope, goes with my independent variable. Now, I keep saying independent. Yes, all these are going to have x's. There's going to be times where it might not have an x, and it might not have a y. So because of that, that's why I keep saying independent and dependent. So what is with x? Negative 3. That's my slope. Okay. And then plus b, or plus 7 in this case. Wow, is it really that simple? Well, let's get a little more complicated. Okay. Y equals x minus 4. So what is my variable? What is my slope? What number is what is the coefficient of my variable x? All right then. I don't see a number. That's scary, isn't it? All right, maybe not. So the variable that is in front of x is 1. That is it. If you do not see a coefficient in front of a variable, that means its coefficient is 1. You guys remember that from earlier in the year. So my slope is 1. So not always is your slope listed. So yes, this is in the form y equals mx plus b because it looks like this. Y equals 1x minus 4. So if you notice, this just looks a lot cleaner and neater. There's going to be so many times when you're dealing with a variable where the coefficient is 1. And if we were at 1 every single time, it would just be so much uglier. More to follow. So now it has to be plus b. This is a negative sign. Now, most of you are saying, wait a minute, minus 4 is the same thing as adding a negative 4. You are right. If you didn't think that, that's fine. Now you can think it. So my slope, my y-intercept is, what number am I adding? Well, I'm adding negative 4. So that means this line would go through the y-axis at negative 4 and have a slope of 1. Now, we don't write it like this. I think you can figure out why. Look how neat and clean and crisp this looks. Look how chaotic this one looks. That's just miserable. And you're going to have so many minuses. Again, I keep saying that over and over again because it's going to happen. These are very basic equations. Wait till they get complicated with like squares and cubes and, fourth, to the fourth power and all that kind of stuff. It's a little crazy. So this is just way too ugly to deal with. So anytime we just see minus a number, that means that your y-intercept is going to be negative in that number. Let's look at this one. Wait a moment! The coefficient here is negative. What in the world is that? Well, what do I multiply x by to get negative x? Correct. Negative 1. The slope in this case is negative 1. Because what this really looks like in y equals mx plus b form is y equals negative 1 x plus x. And again, if you have a lot of terms in an equation, this is basic, but when you get to a lot of terms, this is just going to be really difficult to look at. So it's just understood that it's a negative 1. Okay, my y-intercept is clearly 6. Not very complicated there. All right. Wait a minute. Yes, my slope would be 3, but what about my y-intercept? Is it minus 5? No. It is not minus 5 because this is not y equals mx plus b form. This is y minus a number equals 3x. That's not the right form. I need to get this into y equals mx plus b. So I need to add my 5 to both sides, and now I have y equals mx plus b form. So my slope here is 3, and my y-intercept is 5. Right? Well, Mr. Pro, what about those wacky ones you showed us a couple days ago? Like a horizontal line. How is that y equals mx plus b form? Haha, you have thought too quickly. What is the slope? It was 0. So the actual equation is y equals 0x plus 4. Well, if I multiply anything times 0 is 0, so this is really 0 plus 4, so it's not worth writing. That's why we don't write it. So your y-intercept is 4. Your slope is 0. Now let's get to the next one. These are the proportional relationships. Okay? Mr. Perrault, that wasn't in y equals mx plus b form. Aha! It was. It was really y equals 5x plus 0. See that little 0 down there? Because where did it go through the y-axis? Y equals 0. But here's where that identity property comes back in. In addition, the identity property of addition is you add 0, right? Because it's what do you add to it where it doesn't change. So adding 0 changes this absolutely. It doesn't change it. It's useless. Okay? Well, yes, it will help you in the beginning of y equals mx plus b to know where it goes through the y-axis. However, you just learn to understand, if there's nothing there, it goes through 0, 0. Okay? How do we take an equation and turn it into a graph? Well, we need to identify our slope. In this case, it's negative 3. And our y-intercept, which is 3. Okay? So we first start by plotting our point at the y-intercept. So the y-intercept is 3. Boop, boop, boop. Right there. Okay. And now I need to have my slope. My slope is -3. Now remember, the slope is a ratio. So we need to write this as a fraction. So -3 as a fraction is -3/1. Now that means I go down 3 spots and I move to the right 1. Okay, whoops. Down 3, 1, 2, 3, and I move to the right 1. Now, is that the only way I can do it? No. Okay, because it just means one has to be positive, one has to be negative. So we keep doing the rise as negative and the run as positive. You can switch that. You guys can do that. If I do a positive rise, I need to do a negative run. That'll give me the same thing, right? Because positive divided by negative is negative. So now I just connect the dots, la, 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 connect the dots. Not so bad. I have graphed from the equation. Let's go to the next one. No way, Mr. Prod! We got a fractional slope! That's fine. Remember I told you about that with slopes? When you start to graph it, it's significantly easier if it's a fraction as opposed to a decimal. Trying to graph 0.5 is kind of miserable. Okay, so my slope is 1/2. My y-intercept is -2. So we got to find, okay, where does it go through the y-axis? -2. Where is it? Oh, right there. Next, my slope is 1/2, which means I go up 1 to the right 2. Up 1 to the right 2. And I'm just going to do 2 points for this one. And connect my dots in a straight line. And voila, I now have made a line. So now your y-intercept, if it asks you for the y-intercept, obviously it's -2. Now, yes, I know the y-intercept is 0, -2. I get that. But because when we say y-intercept, we know it goes through the y-axis. We know the x component is 0. The x-coordinate is 0. So we just say -2. You can also say 0, -2. But I think in big ideas, it's going to put it as -2. Same thing for your x-intercept. You say your x-intercept is 4. Okay, we know it's really 4, 0. We know that. But sometimes we just say it because we understand, okay, one of the coordinates is going to be 0. So if it's the x-intercept, y has to be 0. If it's the y-intercept, x has to be 0. Now let's look at an application to one of these. All right, the cost y in dollars of a real taxi, of taking a taxi x miles, is represented by the equation y equals 2.5x plus 2. Graph the equation, interpret the y-intercept, and slope a. Okay, so you notice that I don't have 4 quadrants here because you can't have a negative distance. You can't have a negative money in this situation, okay? The charge can't be negative. So, yeah, basically the way it works is, all right, it's basically saying it's you start by paying $2 and then you spend $2.50 for every mile. So, 2.5x plus 2, so my slope is 2.5. My x is 2. I'm sorry, my y-intercept is 2, so I put my point at 2. Okay, now, it has a slope of 2.5, so we want to make that into a ratio. So that's 2.5/1. Again, not super easy. It's kind of easy to have integer over integer, so that's just 5/2. So I go up 5. 1, 2, 3, 4, 5/2. Okay? I can't do another one because I'll go off the line. Now, I'm not going past this. It starts from your y-axis because as soon as you get, technically, if you don't go anywhere, it really costs you nothing. But this is like from the time you get into the taxi. As soon as you get in there, $2. Okay? So that's why it starts there. It's a terrible straight line. But whatever. That's why we usually use rulers on grid paper. So much easier. Okay? So now we didn't label these. This is going to be miles. And this is going to be, cost. Now I can't just leave it as cost. I have to put dollars. So we know what the money is. Okay? Because if you listen, you go to Europe, it's in euros. You go to England, it's in pounds sterling. Very different. So what does this mean? Okay, so it means if you don't go anywhere, you just get in there, they're going to charge you $2. And then the slope is 2.5, which means that for every mile, you get charged $2.5 or $2.50. Good luck today. Please reach out to me if you have any questions. Bye.